So question 8 says factor the polynomial completely. Notice this actually is a binomial. It's a two-termed expression. So one of the things we can pick up on is when a binomial is connected by subtraction and each term can be written as a perfect square, the binomial is called a difference of squares. The following formula can be used to factor this type of polynomial. So we'll get into what we call perfect squares. Now, if you don't know your perfect squares, you can use your calculator to create a table. So if I hit the y equals button on your calculator, so this little y equals button, notice how you got this little y1. If we type in x squared into that spot, so x is located right here next to the green alpha key. See how there's x, capital T, theta, and n. So if I hit that key there, it's a hotkey for x. And then the power 2, there's a hotkey down here that's got this little x2. That makes the power of 2. So what I can do there is if I go to the table on this calculator, but notice how the table's in blue. So if it's in blue, you have to actually use the second key. So if you hit the second key, it'll actually do what's in blue. So hit second, and then this will actually do the table. Notice how, 0 squared would be 0. So 1 squared is actually going to be 1. 2 squared is going to be 4. 3 squared is going to equal 9. 4 squared equals 16. 5 squared is equal to 25. 6 squared is equal to 36. 7 squared is equal to 49. 8 squared is equal to 64. 9 squared is equal to 81. 10 squared is equal to 100. 11 squared is equal to 121. And 12 squared is equal to 144. So if we look down through there, you can kind of see these are our perfect squares. And the numbers to the left are what's squared. That gives you that. So notice how 13, if I square it, it's going to give me the 169. 12 squared gives me this 144. So I have this table of squares. So if I look at my question, x squared minus 64. Now, again, the calculator can't do variables. It can do numbers, though. But notice how if you actually square an x, it actually gives you x squared, because x squared is the same thing as x squared. So if you look at the 64, notice how it's part of my table. 8 squared gives me 64. So I actually change 64 to a perfect square. It's the same thing as 8 squared. So since this is what's called a difference of squares, I can follow this formula that says if you have a squared minus b squared, I then can write this as x minus or a minus b times a plus b. So notice how the x is actually going to equal your a. So this x is actually your a, and this 8 is actually your b in my formula. So I can apply that to this problem and say x minus 8 times then x plus 8. And that will give me the factorization. Again, you can check it using FOIL. If you want to check this, you could go, you can go x times x, because that's the first terms. And then you can go the outer terms, x times 8. So that's going to give you this x squared plus 8x. And then you multiply by the negative 8. So negative 8 times x, and then you go negative 8 times 8. So when you do that, you get negative 8 times x is going to be negative 8x, and negative 8 times 8 is negative 64. And if you bring this all down, notice how the outer and inner terms actually zero out. And that's why this is only going to be a binomial, because the middle term actually cancels out. So that would be the check. So that would be the correct factorization, is this x minus 8 times this x plus 8. So that would be the solution to this problem. So the factorization of this would be then x minus 8 times x plus 8. That's now what we call factored because it's binomial times a binomial. And each of those binomials is actually called a factor.